Hi guys. The first video is still processing. It's taking a long time for YouTube to process that video, but I did put a link there. So if you click on the link and if it still says we are processing this video, check back later. I see the same screen, but I can't really upload any more videos on Canvas because I used up all the space. So please wait for that link to come back alive. Maybe the last one was too big or too long, I'm not sure, but I'm just gonna go ahead and finish the objective 2, second objective, page 3 and 4 of this. Let me zoom in to see if you can read better. Okay, now you can see this now. Objective 2 is to evaluate concentrations. Let me go over 2 examples with you in this video, and that should be enough for 4.2 homework. In biology class, you have 15% chemical solution, but we need to dilute that to 5%. So let's find out how much chemical we have. If you have 100 milliliter of 15% solution, I'm going to find out how much chemical we have in there. Chemical equals 100 milliliter times 15%, or 0.15 for those of us who don't have a calculator or a scientific calculator. I'm sorry, the percent. But what's that going to be? That's going to be 15 milliliter, right? So that's how much chemical is in this current solution. This is how much chemical we have. Chemical. Oh, I already labeled it. But anyways, so what we have to do is, well, we're going to add 25 milliliters of water. What is the concentration of the new solution? Remember how to find this part over whole, right? And we're going to multiply that by 100. Take a look. The chemical, this is going to be the part. We have 15 milliliters of chemical in there, and we're not adding any more chemical. Now, it used to have only 100 milliliters of water, right? But we are adding how much more? 25 milliliters more. Oopsie. Then, if I add the new denominators, I will have 15 milliliter over 125 milliliter. Oh, I forgot to multiply this by 100. Well, I'm about to. This fraction had to be multiplied by 100. I want to multiply this by 100. So notice the units cancel out right here. Milliliter over milliliter, that's gone. So let me get the scientific calculator and do this. 15 over 125 times 100. Let's do that. 15 over 125 times 100. That's going to be 12. So therefore, the new concentration is going to be 12%. Alrighty, let's keep going. Now, if you have 100 milliliter of 15% solution, so same scenario, we still have chemical is 15 milliliter. But this time we're adding 50 milliliter of water. So let's do the part over whole times 100 one more time. The part is still 50 milliliter, right? But the whole, we used to have 100 milliliter of this solution, but we are adding 50 milliliter of water. So that's going to be 15 milliliter over 150 milliliter. And we're going to multiply that by 100. So notice the milliliters cancel out. So if you do 15 over 150 times 100, we'll be able to get the new solution concentration. 15 divided by 150 times 100 is going to be 10. Therefore, the new concentration, the concentration of the new solution is 10%. Now, what was the goal? Now, let's see. They wanted it to be diluted to 5%, right? 5%. We're getting there. Take a look. We added only 25 milliliter of water, then we got 12%. But if we added 50 milliliters of water, then we got it down to what? 10%. We want to keep on adding more water so that it goes down to 5%. So part C, how many milliliters of water should be added to? Well, do me a favor. I want to keep on doing the same number. Can you change that number 75 milliliter to 100 milliliter? Because I want to keep on using the same problem. There's no reason for me to go back to some other solution right now. So how many milliliter of water should you add to 100 milliliter of the original solution to get a 5% solution? Now what I want you to look at is the setup that we were using. I'm going to go ahead and highlight this right here. Maybe like right here. Like maybe that part right here. I'm going to use that, okay? Now, what we know is we want the other side of the equal sign to be 5%, right? We want it to be 5%. So I put 5 right there. The other side is going to be, well, we are going to be multiplying that by 100. But then the fraction is going to be 15 over. Well, the chemical is still the same. But remember, we start with 100 milliliter in the beginning. But then we're going to add X amount of water in there. So my X and multiplying symbol look confusing. So let me just change this to like multiplying. Okay. So now that's what we have. We're going to have, do you see how this is similar to what we were doing above? This is similar to doing 15 over 100 plus 50. Well, we knew that was 50 back then, but we don't know the amount of water we should add. So we called it X here. But then still multiplying that by 100. But what we know on the other side, we want it to be 5%. So hopefully this setup makes sense. Let's go ahead and solve for this. Let's go ahead and divide both sides by 100. If I divide both sides by 100, I will get 15 over 100 plus X equals, let me make notes here. Dividing this by 100, dividing by 100. This is now gone. And the right side is going to be 0.05. Now, to get rid of this fraction, I will multiply both sides by that denominator, 100 plus X. I'll multiply both sides by 100 plus X. If I do that, this denominator and that 100 plus X cancels out, leaving us with just 15 on the left side. And notice on the right side, we're going to have to yeah, you know what? I will distribute. We didn't have to, but we can distribute both sides and get 5 plus 0.05x, right? All right, subtract 5 from both sides. This one is going to be considered a little more than the first two parts, but we can do this. What we're going to get is the 5 canceled out, and we get 0.05x equals 10. Divide both sides by 0.05. We'll be able to find how much water should be added to make this solution 5%. So grabbing my calculator, I'm doing 100 divided by 0.05. And that comes out to be 2,000 milliliter. Oh dear, that sounds an awful lot. Too much. That sounds too much. So I'm double checking my answer here. 100 plus 2,000. 1 divided by 140. Something went wrong, guys. Something went wrong. I better fix what went wrong here. Give me 1 second. I'm checking, okay? What? Oh, I'm being so silly. It wasn't 2,000. It was only 200 milliliter. So sorry about that. That was silly. So the answer should be 200 milliliter. When I saw 2,000, I was like, that's way too much. How in the world did I get 2,000 in the beginning? I just typed up. Yeah, I just typed. Oh, I did 100 divided by 0.05. I should have done 10 divided by 0.05. Sorry about that mistake. But then the answer should be. So this is what you can do to check. So let's do the check here. Check. Do 15 divided by 100 plus 200. And multiply that by 100 for me, okay? If you do that, you'll get 15 over 300 times 100 You can do that on the calculator, but I notice I can simplify this to 1 and 3. So 15 divided by 3 is going to give you 5. So that checks. What I just did on the side is just me checking the answer. Well, guys, this part was a little more challenging than part A and B. But we're using the same exact setup. We're just solving it backward. That's what made it a little more complicated. But here's the answer. X equals 200 milliliters. We have to add that much water in to the original solution to get 5% solution, okay? Alrighty. Let's go ahead and, why did I delete that? Let's go ahead and look at the very last example for this lesson. Now, number 5. Now this one, I almost wanted to take away this table from you because it can be done without this table. But having this table makes it really easy because we can just really set up. By the way, guys, I just saw that on my YouTube. It got published. So it's okay now. It's going to work now. It just took a long time, though. It really took a long time. I'm sorry. Let me go back and keep on talking about number 5. After number 5, you know what? That's it. Because we decided to skip the classwork sedative. Because you have my math lab homework to try. So I'm going to skip this last page. So you don't have to do that one. But let's do the very last example together. Number 5. Your vet is administering a sedative for your 50-pound dog. We have a 50-pound dog. Okay. The sedative is mixed in saline solution. Okay. Unfortunately, the solution is pre-mixed at 10% for a horse. Oh my goodness, that's going to be too strong for my dog. And it needs to be a 3.5% concentration to be administered. Oh, so guys, look, the 10% solution is for horse, but for my 50-pound dog, I need it to be 3.5% concentration. And that's going to be administered at 0.9 milliliter per pound for your dog. Oh, a lot of numbers we were just given. How much saline water needs to be added to the current solution to reduce the concentration to 3.5% and have the correct dosage for the dog? And guys, this is important, right? We don't want to give too much sedative for our dog because he's going to be gone. We want to make sure that we put enough water or saline water into this current horse medicine so that it's going to be not too strong for our little dog. So you understand the problem. It's got a lot of parts to it. So we'll go through A through D together. And by the time we answer all those questions using this nice looking table, we will have the correct dosage for, we will get how much water needs to be added to make this a correct dosage for the dog. Okay. All right. How much milliliter? And you see they use the letter N. What they are saying is they want you to find N in this table. So notice N is right here, right? And look at me. Look at what I'm doing, okay? I am boxing 4 other boxes or 3 other boxes around my N. And one year I just got rid of this table, guys, and just taught it without the table. And when people went and did homework, they had the table. So they're like, why did we not use the table? Yeah, let's use this table. Table makes it very easy. They want you to find the N value. How many milliliter of the new solution, 3.5%, should be administered to the dog? Okay, so look at what I highlighted in orange for you. Just create a proportion using those 4 numbers. So 0.9 over N equals, notice where I got those, right? 0.9 over N, that equals 1 over 50. Now, let's talk about what we are even doing. Now, remember they said something like this before. They did mention they want you to use 0.9 milliliter per pound for your dog, per pound. So if I have a tiny little dog who is 1 pound, then this dog will only need 0.9 milliliter. But we got a dog that is 50 pounds heavy, 50 pounds. So what we are going to have to do is we're going to multiply that by 50, right? That dosage or that 0.9 milliliter by 50. And if we just solve this, we're going to end up actually doing that, right? So that's going to be 1N, or simply N equals, here we go, 0.9 times 50. and N is going to be 45. Now let's remember the unit. How many milliliter, right? 45 milliliter. So my dog, my 50-pound dog, will need 45 milliliter of this, how should I say, of this solution. So what I'm going to do is I'm going to go ahead and get rid of my orange highlight right here. And then just going to write down 45 in this blank, okay? N equals 45. Just like this, we're going to be using clues because we'll look for at least like 3 values. Yeah, we just need 3 in order for to find the 4th unknown value. So let's see the next part. How many milliliters? And this time we're looking for S, right? Let's looking for S. How many milliliters S of the sedative are contained in the dosage of the new concentration, 3.5%, that should be administered to the dog? What I'm going to do is I'm going to find S in my table. Where is S in my table? Notice S is right here, right? S is right here. And what I will do is I will look for 3 other quantities in this table that I can use to set up a proportion, okay? What do you guys see? I'm looking. Oh, guys, I noticed something. Now, take a look. I had to look for just a little bit. I'm going to highlight what I noticed. There is S right here, right? There is S. And there is this 45 that we just found together. S and the 45. And if you look, 2 above these 2 boxes, there's 3.5, and there is 100. We're going to use those 4 quantities that I'm just highlighting in purple. Hopefully my colors help you see these 4 quantities. They're in the exact same positions. I can set up a proportion using those 2. Look, so I'm going to make it 3.5 over S, okay? 3.5 over S equals 100 over 45. 100 over 45. I didn't bother to look for any other proportion, but that's enough for me. 45 is the answer that I found on part A. When I fill that out in my table, I can use that now. Alrighty, let's solve for S. Multiply that by 100. I'll get 100S equals 3.5 times 45. 100 times S is equal to, all right, let me get my calculator. 3.5 times 45 is 157.5. Now divide both sides by 100. S is going to be 1.575. Now let me check the unit. Milliliters. Okay, so that's that. I found S. I'm going to go ahead and erase some of my orange highlights. And just going to write down my S. That my S is equal to 1.575 milliliter. Now, what does that mean? I mean, I found the answer using this proportion, but now I better talk about what this even means here. So what we just found out is that how many milliliters of sedative are contained in the dosage. Okay, to give to our dog is going to need 1.575 milliliters of sedative. Okay, out of the total 45 milliliter solution, 1.575 milliliters should be the sedative to make our dog sleepy. So that's what we found. And compared to the dog sedative, not the dog, horse sedative that was 10%, that's probably going to be much less, right? I guess they talk about the original solution. Well, all right, let me go on. Okay, because we found S. Now C, how many milliliters? O, okay, the letter this time is O. Of the original solution, 10% contained the sedative in the dosage that should be administered to the dog. See, I hated using the table because I feel like I'm just making this easy by using these proportions without really solving the math problem, but why not? It's given to us, so we'll use it. Let me go find O, okay? We are trying to find O this time. So let me highlight the O in red. O is right here. Now what we want to do is we want to find at least 3 other quantities that we can use to set up a proportion. Okay, so I'll let you take a look. I'm going to take a look too. You know what, guys? The one number that we just found. The one number that's immediately next to it. Let's use the S. That 1.575 that we just found. And take a look at the very top row under the labels. We have 10 and 100. Notice that that's going to be perfect. That's enough for me to set up a nice looking proportion. Let's use these 4 to set up a proportion. Ready? 10 over S. Write that. 10 over S. Now hold on. What's S? 1.575. We found that on part B. Equals, let me go back up. 100 over O. 100 over O. And that O is what we want to find this time. And O looks like 0, so let me just make it look like an O, like I added a little hair right there. Okay, let's solve this. So that's going to be 10 times O equals 1.575 times 100. 10 times O, how can I, maybe I can do it like this. O equals 157.5. Divide both sides by 10. O is equal to 15.75 milliliter. Okay, so how many milliliter of the original solution contained the sedative and the dosage that should be administered to the dog? 15.75 milliliters. Okay, so let me write that number down in my table, okay? 15.75. Let me delete these first. This was 15.75. Okay. Anything else? I think that must be it. All right, let me go all the way down to see if we have any other parts left. Oh, here we go. How many milliliter of saline solution should be added to the amount of the original solution, 10%, to get the amount N of the new solution that should be administered? Oh, okay. So let me see. We have O. Let me write down what O is that we just found. Is 15.75 milliliter. And if you're wondering why are you writing down O, it's because we need to go from O, the original solution, to the new solution. And the new solution, the amount for the new solution, let me write that down. N equals, we found this somewhere, right? Let me go find N. N was 45 milliliter. You see right here, N is 45 milliliter. That should be the new amount for the dog, 45 milliliter. And here's the question. How many milliliter of the saline solution should be added? How much should be added to this 15.75 so that it becomes 45 milliliter? Okay, and we can simply do that by doing N minus O, right? So do 45 minus 15.75. Let me use my calculator to do that, okay? 45 minus 15.75, it's going to be 29.25 milliliters should be added. That should be added. Now, using the table, we solved this. I was going to ask you to try that classwork sedative about a 40-pound dog, Bella, but you're gonna see these problems again on your homework, I think. So that's probably enough for this week's lesson, this Monday's lesson, because I have more coming for you on Wednesday, right? So I'm gonna also go ahead and post this worked out copy on Canvas for you. But as you saw, I was highlighting, deleting, erasing the highlights, highlighting again, erasing the highlights. So it's gonna be much helpful for you to, I mean, if you're listening to this right now, you probably watch the entire examples. So thank you so much for watching. If you would like to talk more about this, please email me to set up a virtual office hour, okay? Alrighty. I'll come back with project 1, a short video to go over the first 10 slides of the project 1, okay? Alright.